Alright, problem 35. Part A. So we got this rope we're using to pull a block along at constant velocity. Constant velocity means the net force on it is 0, right? And we do it for constant velocity for 4.06 meters. The force of the rope is 7.68 newtons and it's 15 degrees above the horizontal. Okay, so we're pulling along. Let me start over. We're 15 degrees above the horizontal. That means this force, right, is 7.68 times the cosine of 15. And then that force is 7.68 times the sine of 15, right? That also means that 7.68 times the cosine of 15 is canceling out exactly the kinetic friction because the block is moving at constant speed, which is right there. It's moving at constant speed, right? So F in the x direction that we're applying is 7.68 newtons times the cosine 15 degrees. Right, 7.68 times cosine equals 7.68 times cosine of radians of 15, 7.42 newtons. That also means that the force of friction is minus 7.42 newtons. Okay. Now, the force in y is 7.68 newtons times the sine of 15 degrees. So the force that we're applying on y is 7.68 times sine of radians of 15 is 1.99 newtons. Okay, that's important. Part A. What work is done by the rope's force? Okay, so the work done by the rope is the force it's applying in x times the distance, which is just 7.442 newtons times 4.06 meters. Okay, 7.42 times 4.06 is 30.1 joules. All right, part B. The increase in thermal energy of the block force system. Okay, what is the increase in thermal energy? Well, the increase in thermal energy, this is the work done by the rope. The increase in thermal energy is equal to the work done by friction. And so the work done by friction is also 30.1. It's also 30.1 joules, right? So this is the work, the energy that leaves the system to the environment. So we out of the kinetic system, right, the work done by friction is going to be minus 30.1 joules. That energy is lost to the environment and becomes thermal energy. And so because it's lost to the environment, it's positive in the environment and increases the thermal energy of the environment by 30.1 joules. Okay, part C. The coefficient of friction between the block and floor. The coefficient of friction. All right, so we know that the force of friction, Fk, all right, in this case 7.42 newtons, I'm not giving it a sign here, times mu k times the normal force. Normal force. What's the normal force? If normal is mg, all right, so mg is the weight of the block, but we are picking up on it right up here by 1.99 newtons, so minus Fy. So the weight of the box minus Fy is the force of the box down. The normal force is equal to that, and that's mg minus Fy. So the normal force is 3.56 kilos times 9.8 meters per second squared minus 1.99 newtons. Okay, equals 3.56 times 9.8 minus 1.99, 32.9 newtons, right? 32.9 newtons is the normal force. Since we know that mu k is going to be Fk over Fn. That's 7.42 newtons divided by 32.9 newtons, and we get a mu k. 7.42 divided by 32.9 of 0.23 or 0.226. 0.226 is the coefficient of kinetic friction between the block and the floor. And that's it for problem 45.